Good morning, everyone. Welcome back. All right, guys. We have spent much time to talk about definition and of trig function. What I have in mind for today is that I want you guys to fully appreciate the definition, okay? So for that purpose, for that end, okay, I have designed quiz number 10, okay, which is not a special angle, right? You have to use definition and you have to give the exact answer for that quiz. That there's 32 points on it, right? So today, number one, I'm going to show you, and we're actually going to do it together to do the definition. How do we do the definition, right? So I'm going to bring back up the definition we just covered yesterday, not last week, right? And with that, we're going to the full definition, okay, the original definition. So that's what we're going to do today, and we're going to do an example together. Okay, we're going to do an example together. And are you guys ready? Yeah? Yes or no? You ready? I know some of you have started doing the quiz and have some questions, and I think I would do justice to the definition if we do it in class. Okay. Remember, I once promised you guys I want you guys to see math in a simpler term. Okay. But that is not without a lot of work. To get to that point, we need to do a lot of work. So that we need to adopt a certain way of observing the situation instead of just go and run. We need to, in other words, you can say, stop and smell the rose. And of course, we don't have a rose to smell. And typically we stop and study the definition. Okay? So treat that as you stop and smell the rose. Okay, whether you agree with me or not. So let's do it. Okay, so I draw this circle here. So I mainly want to just recap and see what I really want you to understand about this definition. We know that before we introduce a definition, right? We talk about A, right? We talk about A is the angle measurement, how we measure the angle. These angle measurement, okay, because why this angle is so important? Understand this angle is so important because it is the input. It is the input to all of the functions, to all of the 6 trig functions, okay? Sine of A, cosine of A, tangent of A, cotangent of A, right? And cosecant of A and secant of A. Okay, and they produce what? They produce output. And what are those output? Those output are ratios, right? So all of these each have their own rule. We have 6 rules here. Okay, if you recall the definition of function, a function is a rule. Now we have 6 rules altogether introduced to us. So we must understand these. We must understand what they are. We understand what's the input, what's the output. And the ratio is just the ratios of various kinds. Okay, so this exercise we're going to do together today is to better understand that. to better understand that. Okay, so for that reason, to that end, I'm going to bring back the definition and we're going to do a concrete example. We're going to do a concrete example. And you can see I already have the example ready for you. I already have the example ready for you, right? With that stage set, right? A is we discussed A, we decided reference angle, and we have a point on X on the terminal side of A other than the origin. So that's the point. We have a point, right? X comma Y. But for this exercise, I have selected 4 points for you. Each one of the 4 points is on a terminal, okay? And they happen to be on the first quadrant, second quadrant, third quadrant, and fourth quadrant. So I want you guys to carry through these calculations. And of course, I'm going to take the lead. I'm going to show you what is expected of you to do, okay? And so you have a glimpse of the quiz, what's expected of you to do on the quiz. And then I'm going to do some, and you are going to do some independently, and we'll have the breakout rooms. And so you can work with Farouz if you wish. Okay, and of course you can still stay with me. So now with that stage set, let's review what is the definition of sine. What is that ratio? It's y over r, right? How about cosine? X over r, right? They're all ratios. So input are angles, output are ratios. And tangent is y over x. Cotangent is what? X over y. And then what? Cosecant, r over y, and secant is r over x. Okay, r over x. Ratios, input, output, input, output. Okay, now, with the concrete example we have here, right? So I'm going to put the narratives here. I'm going to give you the narrative here. If A is measured from the standard position, okay? A is measured from the standard position. Okay, on this terminal, the terminal in the first quadrant. Okay, the terminal on the first quadrant. 5 over 12. I'm sorry, 5 comma 12. This point is a point on the terminal. So I have chosen that point for you. So what I like you guys to work out, and I want you guys to work out that angle, and you're going to find the ratio. For example, with 5 comma 12 given, right? What do we know? What do we know about x, y, right? So x is what? X is 5. Y is 12. And what is r? By definition, r is equals to x squared plus y squared. Right? And then what? We plug in the number 5 and we plug in the number 12, and we're going to get a square root of 25 plus 144. Okay? And that is equals to square root of 169. You can see I made these choices in order to get some numbers that are not so messy. Okay, so we have x, we have y, we have r, right? So what I need you guys to do, let's do it with me. Could you guys do that with me? So x equals to 5, y equals to 12, r equals to 13, right? And what will be the ratio for A? Sine of A is equals to what? What would that be? Y over 12, right? Y over R, sorry, Y over R. So that's going to be 12 over 13. Keep it that way, okay? The other instruction, I have it on quiz number 10. I'm asking you guys to give the exact value. Some of the exact values has a fraction form and it also has a decimal form. And some of the exact values has only the fraction form. It doesn't have the decimal form. Why? Because if you get the decimal form, you have to round. If you round it, the resulting number is no longer exact. Okay, the rounded number is no longer exact. And all of your professors, I would say 99.99% of the professors who teach math in your academic journey, they all wanted the exact value, if possible. If possible, you know, in statistics class, you know, we have to compromise, but we still want to have as exact as possible. I don't know why, but anyway, that's a matter, that's a fact of life. All the math teachers in the world, they want to have the answer as exact as possible. And you want to get points from them, don't you? And what do? Just give them the exact. Sometimes it saves you the use of a calculator. You don't need to use a calculator. Okay, do you guys understand what I'm saying? So it's not just me. Everybody, almost every math teacher you're going to encounter now and in the future. Well, okay. So just get over it and move on with your life. How about that? You can't change them. You cannot change these math professors, right? They're so nerdy and so stubborn, right? Just do it, just do it. So X over R, so I'm going to give you more explanation about this. X over R, so 5 over 13. The numerical answer for 12 over 13, if you get a decimal, if you put in a calculator, you get a decimal number, they're going to have many, many digits afterwards. Okay, so whatever answer you give for that decimal answer is not exact. So in this case, the best answer you can give is 12 over 13. That's it. You don't need to even touch that calculator. Okay. For 5 over 13 is similar. Do you understand what I meant? Sometimes you may have like 5 over 2, 5 half. Then the answer, the exact answer will be 5 half or 2.5. Either one is okay. And they will be accepted. Okay. But sometimes it turns out to be only the fraction forms is the exact form. Then just use the fraction form. Okay. Sometimes only the square root of 2 over 2 is the exact form. So don't get the decimals. Just use square root 2 over 2. Okay. All right. So with that said, and let's look at y over x. Y over x, that's going to be 12 over 5. Right? How about x over y? X over y is 5 over 12. R over y, what is R over y? 13 over y. Y is 12. So there's 12. And the next one is what? Is 13 over 5. And you're done. You're done. So that's one of the points. That's the point in the first quadrant. Do you guys want to try the point on the second quadrant? Shall we? It's your turn. It's your turn. Are you ready? So this terminal, okay, there are lots of angles that was this terminal. So now we pick a point. I pick a point for you. We pick a point on the terminal other than the origin. And next, you are going to work on the point negative 5/12. I'm going to give you a couple minutes to do. Is Farouz there?
Yes, Professor.
Okay. Well, we'll see. If any one of you want to go to the breakout room, feel free to do that. Let me know. I can open up the room. You guys know what to do, right? So now you're working on this point. I'm just going to mark the points with letter. Okay, so this is A. So now you're working on B. Okay, so the B point. The B point. Okay. B point. Point B, which is going to be that. That's a B point. Oh, that's too bold. B point. I'm going to make it lower. And the fonts. B point. Are you guys working on that? Anybody want to go to the breakout room? You know what to do, right? You know what to do for B. So now you're working on the B. X is negative, Y is 12. Okay, X is negative, Y is 12. So I'm going to mark the C's and D's. C, 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 C. I'm gonna move it to this is negative 11. Okay, so that's our C. Still. Do you guys want me to open the breakout room? Yes or no? You guys okay? This is just sometimes it could be very time consuming. Okay, this should be better. C. 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 I see this is so troublesome for me. Okay, that's C. It's still so weird. Anyway.
Professor, I may have some tricks and techniques to share with interested students if they join to breakout room. So you can open up breakout room. I'll let you know if we have
Okay.
any.
So let's see who wants to break out. Oh, you guys give me a bunch of answers there. That's great. So I'm going to open the breakout room. Do you guys want to go there? Or I can give Farouz a few minutes to let him share his work. Do you guys want to do that? Farouz, let's try that, right?
Yes.
Okay, so let's see how I do that. I should give you allow participant to share screen. Do you see that? Can you share your screen now?
Oh, you want me share my screen?
Yeah, I have give you permission.
Oh, okay. So let me get ready.
So now you're just addressing to everyone. I'm going to give you like 4 or 5 minutes.
That is good idea. So let me go with the share screen here. You cannot start the screen share while the other participant is sharing. So yes, you are sharing now. It says I cannot. Okay. Let me try again. Share. All right.
Okay, I want you guys to see Farouz's perspective, okay?
Share my screen. Let's see where I'm gonna share my screen. One more time. Share screen. I guess I cannot share for some reason. Let me see what else I can do, person. If the students see my board, do they see clear enough, large enough? Is that something?
I actually don't see it.
Okay, so let me stop sharing. How about now?
Share screen.
Can you see the board good?
You can if you pin Farouz.
Pin. Yes. So thank you, pin. Are we good? Yes, everybody can see.
I thought I give you share screen.
Oh, share a screen. Okay. Now. How about now?
I don't see it.
No. Okay. So
it should be the entire screen, right?
So this is the
I can see Farouz's board.
Yeah, I think we can see his board. I think when he shares the screen, it shares his computer screen and not his whiteboard.
I see. Do you see his what he wants to show on the screen?
On his whiteboard, yes, we can see it. But only when he's talking, because then it pops up.
Huh.
Because
I don't see it as I see it, but it's not large enough for me. You know what I mean?
You can go to view and then speaker view, and it will show you just the speaker blown up, and it will show his board better.
So am I going to be selecting?
There, you're right. Go to speaker, go to view, and then click the speaker view.
Let me see. Speaker. Let me see. Speaker.
Not Farouz, but everyone else.
Oh, okay.
So everyone else can go to view and then speaker view. And then if you click the 3 little dots next to his name, next to Farouz's name, you can also pin him. And that way, no matter who's talking, you'll still see Farouz.
Thank you. How do I pin it? Farouz, say something.
Yes, I'm here.
Okay, so now how about you go ahead and explain?
Yes. Okay. So a couple of these points. Point B, the column for point B is here. X is -5, Y is 12, and R, based on the formula, r equals the square root of x squared plus y squared comes up r equals 13. So we did all those. Basically, we plug in these values. So sine A is y, 12 over -5. Sorry, I take it back. Y is 12, R is 13, 12 over 13, sine A. So, and straightforward, these are so easy, probably that's why Professor and me realize you may not even need help. Maybe it's so obvious, but please interact and ask questions while I'm trying to explain. Is there anything, any question here? Is it straightforward? These are all based on definition Professor mentioned. So we use the X. Remember, this is point B. Point B is in the second quadrant. X is negative, Y is positive, R is always positive. So if I make any typo, please let me know real time. Y for tangent A, Y is 12. X is -5. This might be similar, you might see similar question on the quiz, right? So it's not going to be a tricky question. It's just as simple as when we learn everything about the lecture, right? And practice, apply it. So cotangent A is x over y. X is -5, y is 12. Please interact and ask any questions so far. If there is any question, let me know. Cosecant A, by definition, is r over y. R is the radius. R we calculated. 13 over y, 12. So, and finally, secant A is r 13 over x -5. And then you might want to fine tune the answers. If the negative is in the numerator or denominator, you can write it in front of the fraction. But this is still fine answer. These are the exact answer. Also, something regarding the exact answer, Professor mentioned, you don't want to use a calculator to write the answer in the form of decimal, especially when they're not terminating. So those are approximation. Therefore, also, as you see, point D is going to be exactly the same process. The only difference is y is positive, x is positive, y is negative. And then we just plug in the values. Now, something about that exact answer. This is a calculator, less than $20 plus tax. This is the model number. This is a brand model number, second edition. If you don't go second edition, you are going to see it for 80 bucks or something. But if you go for complete model number with the second edition, that is less than $20, okay? Still doing same thing. So you don't want to pay 4 times more than what you can pay, get the brand new. Price is less than $20, tax included. Where? Amazon, Office Depot, Walmart, any place, every place. So if you get the right calculator, for example, natural display, it can help you, but professor suggests use your true calculator, which is your brain, okay? And learn how to answer these questions manually without the using calculator. Then you can use a calculator to confirm it, right time, right place, okay? And then that is a calculator issue also, yeah. Calculator is gonna be there to save your precious time during quiz, exam, final. And you want to choose the best calculator, not any scientific calculator. And that is my suggestion, in case if you are in process of choosing a calculator, get it inexpensive and so powerful scientific wise. I call it superpower scientific plus.
Okay, guys, I think I'm gonna stop this sharing. Thank you, Farouz, for your time.
You're welcome. Thank you, ma'am.
Okay, there are a couple of things I'd like to address. He did a great job, and his handwriting is absolutely beautiful, which I always appreciate some beautiful, nice handwriting. Now, when we come back, I basically copied his work, right? Sine A, right? Sine of the angles, which is the angle has a terminal at a B, right? Point B. Okay. So now we're working at point B. Okay, just for you. So we have written down that X is -5, Y is 12, and R is 13. R is 13 here. Actually, I wish you to do the following. I wish you to go through the steps and okay, just do some numerical calculation. I think some of you probably need to do this to review your basic algebra. Okay, so you just plus 12 squared. But this time you have a -5 squared. So as a result, you're gonna have, okay, so in addition to what Farouz did, I want you guys to do this as a review for your basic arithmetic, okay? So this is gonna give you 169 in square root, and the final answer is 13, okay? So for each one of the point, I want you guys to see the relevant, to calculate the relevant R just for your own practice. Now we have X, we have Y, we have R. And R is 13, right? R is 13. Now, Farouz had to work out all these answers, okay? And the best answer to the first one would be, actually, this is the only exact one. The second answer, however, there are 3 forms. You can have, this form works, and this other form will also work, which is 5/13. You put the negative sign in front of it. The third form actually is 5/13. All 3 numbers are identical. It's just you can put a negative sign at different places. Which one is the favorite? If you write it on paper, this is the favorite. This is usually preferred. But all the other 2 are correct. They're correct as well. Do you guys follow me? So this is just also a review of a basic skill. And for this one, the same thing. You can write as -12/5. So you can see the negative sign. You can put it in the front. You can put it on top. You can put it in the bottom. It does not make any difference. Do you guys follow me? Just in case you didn't know. Okay, in case you didn't know. And 5/12, 13/12, and the last one, 13/-5. You can write it as -13/5, which is a preferred form. Does everybody follow me? So this is just a little, you know, I just added a few comments about Farouz from Farouz's work. Okay, so he did a very good job. He did a very, very good job. And next, okay, we're gonna work the same process for the point C and D, okay? And C is on the terminal, right, in the 3rd quadrant. D is on the terminal in the 4th quadrant. So this time I'm gonna set up the breakout rooms. You guys know what to do, right? Yes? And you can do self-select, okay? Basically, what you're doing right now is similar to what you are going to do for quiz number 10. For quiz number 10, which I want to enforce the definition, the use of definition. Okay, so now let's do it on C and D. C and D. Let's go. So for point C and point D. Point C and point D. Okay, you're going to do the same thing for point C and point D. So for point C, you're going to work out that, right? Which is going to be y over r, x over r, tangent y over x, cotangent x over y. You need to identify x, y, and calculate the r. You got it? Everybody? Do that for C and D. For C and D. If you want to go to Farouz's room and he will be there, and if you want to just stay here and calculate, I'm going to give you a couple minutes.
So Professor, breakout room is not activated. I don't have
I just opened. Okay, sorry.
Thank you, ma'am.
Okay, now the breakout room is open. Okay, remember, think of definition. Think of definition. Take this opportunity as a mean to review your, your working with fractions. For C and D. For C and D. Okay, point D on the other side. B point is so ugly. Need to do something. Okay, let me know if you have any questions, okay? The B point is just a little bit too crowded. 5, negative 5, 12. What becomes so crowded? Negative 5, 12. Let me just scoot over a little bit. That's better. So for C point, X is negative 5, Y is negative 12. Okay, so you're gonna find R by plugging numbers. Please do that. Okay, this will be a good practice for you. And the next one, the D point, X is positive 5, Y is negative 12. And for R, you're gonna find the same, you're gonna use the same formula to find R. And then you just plug in. Okay, then you just plug in. Okay, so that's hopefully that's set. One is for point A, and then one is for point C, and the other one is for point D. Okay, so the points are there. So C and D. C and D. Oh, these points are just so crowded there. -5, -12. Fine, -12. Any questions? Right, so now it's not so crowded. Better. How are we doing?
Doing well.
Good, good. So you finish both?
Yeah, I finished both.
Well, you find these fractions, okay to process them?
Yeah.
Good. Okay, I'm gonna close the rooms and bring everybody back. Okay. There are 19 seconds before they come back. So I'm just going to get started to fill out the numbers. You guys probably already done it. So I'm gonna go a little faster. So this is gonna be -12 over R, which is 13. I do want you guys to go through the steps to find the R. Okay. Because some of you do need to review those basic calculation. Okay. So for this, for the point C, you're gonna have -5 squared. That -5 needs to be in the parentheses. And the other number you're gonna have is -12 squared. Okay, notice how I write them. Okay, notice how I write them, right? And then of course, -25 squared is +25. right? Is a positive 25. Negative 12 squared is 144. You still end up with the square root of 169, but I want you guys to go through that process for yourself. Okay, so it's 13. So R is 13. Okay, so R is 13. Okay, so that's for C. So once we get these, we're going to just plug in, right? Cosine A is X over R, which is a negative 5 over 13. And when you write it, you need to recognize all these are different forms. Okay, negative 12 over 13, right? Or you can also put the negative sign in the bottom. That will not make any difference. But the last form is usually the preferred form. Okay, and the next one, y over x. Y is negative 12. X is negative 5. And negative divided by negative is positive. So which principle are we using? Principle number 6, right? Principle number 6. So 12 over 5 is the final answer. You don't need to make it a mixed number, okay? Just leave it as the fraction. Cotangent is x over y, so it's going to be negative 5 over negative 12. Reduce that fraction, you get 5 over 12. Okay, R is 13, Y is negative 12. So in the end, you get negative 13 over 12. R is 13, X is negative 5. So in the end, you have a negative 13 over 5. Is everybody following me? So these are the answers for C. What did you get for D? Could I see some contributions from you? Okay. First of all, I want you guys to do these. Okay, so for point D, I have a tendency, I think we're running out of space. Okay, so for D, I'm gonna put it here. Okay, that's for D. And for the R, I want you guys to do this. Okay, just go through that process. And this is necessary for you reviewing, because remember, this is 5 classes in one. You guys with me? Some of you need to review fractions. Some of you need to review, complex fractions. There are all kinds of things we need to review, and we need to do them all at the same time. That's what you sign up for. That's what you sign up for. Okay, so point A. Let's see, where's my point D then? Did I lose it? There, D. Okay, my point D. All right, so for point D, wait a minute, that's not the, I need to bring that picture with me, right? I need to bring that picture with me for my point D and my table to work with. So for point D, what I want you to do is that you go through these radicals. Understand you are reviewing those basic maths that we need to review. And you still go through the process with the proper expression, right? You need a parentheses for the negative 12. So here 5 squared is 25 and negative 12 squared is 144. So you do this a couple of times and that's how we get better. So now this is going to be square root of 169. Some of you may find this boring, but I have to ask you guys to bear with me because we all come from such diverse background. We no longer have the prerequisite requirement, okay? So I will make my best effort to teach to everyone. So now y over r is going to be negative 12 over 13, right? X over r is going to be 5 over 13. Tell me if I made a mistake, okay? And in the first one, you may like to write it in the preferred form. Okay, tangent y over x, y over x. Y is 12, negative 12, sorry, negative 12, and x is 5, right? So this will give you the glimpse of the homework, of the quiz you have. Equals to, this is a 5 over negative 12, and that is going to be equals to negative 5 over 12. Am I going too slow or what? So this is 13 over y, y is negative 12. So we observe much in this process, don't we? What have we observed? What have we observed? So this is 13 over 5 equals to, that's just 13 over 5. You're good. 13 over 5 has two forms of exact answer. 13 over 5 itself, or you get a decimal form. Okay, I think it's a 2.6, right? It's a 2.6. You can give either one. So these are just examples. We have done A, B, C, D. Are we good? We've done, you see, why do I choose these 4 points? Why do I choose these 4 points? Each one in their individual quadrants. If you look closely, we will get a glimpse of the signs in each quadrant. Sign of the trig functions in each quadrant. So what are they? Right, from the definition, it has already told us. To help us to see that, I'm going to make a table. Okay. This table, I don't need to have, I need to have a couple columns and maybe just so many rows. That should be enough, right? If we look at the definition, right, I'm also going to bring you a rectangular system here. Okay, the rectangular system here. The rectangular system, I'm gonna bring in, and I want you to see from this point, you never have to memorize. You never have to memorize the sign of sine, cosine, tangent, and cotangent. I promise you. That is the purpose. That is the purpose. Okay. You can see the definition will tell us a lot of things. What does the definition tell us? What does the definition tell us? In the first quadrant, X is positive, Y is positive, isn't it? Okay, so let me mark it quickly, right? I see chat. No good pace. Okay, thank you. If I'm going too slow or too fast, please prompt me, okay? Please just let me know, because this is your class. I'm just here to help you, okay? I'm just here to help you. So on the first quadrant, right? If you look at any particular point in the first quadrant, right? We have X comma Y, right? X is positive, Y is what? Positive, right? What happened to the second quadrant? X is negative, Y is what? Positive, right? In the third quadrant, what happened in the third quadrant? X is a negative, Y is a negative. We have seen those examples in the previous one, right? The fourth quadrant is going to be what? X is positive, Y is what? Negative. Do you agree? Do you agree?
Yes.
as a consequence. If you look at the definition, right? We know sine is a ratio, right? We know sine is a ratio. If there's a terminal that ends in the first quadrant, if a terminal ends in the first quadrant or second quadrant or third quadrant or fourth quadrant, according to its definition, it's y over r, right? We have that context. R is always positive. So whatever sign is for y is going to be the sign for sine of A. Is that right? It's going to be the sign for the output, right? Yes? Is everybody with me? Okay, remember, sine is a rule. Sine is a rule. This sine rule, okay, sine of A is going to produce a ratio. This ratio is y over r. This ratio is y over r. And we want to know the sign of this ratio because y is positive. You see, y is positive in the first quadrant, in the second quadrant and the first quadrant. I'm sorry, I pointed to the wrong place. Okay, why? I'm pointing to the wrong place, okay? Because I was thinking about how to get the, okay, I'm gonna use the blue color, make it a little thicker. The y's in the first quadrant and the second quadrant, they're both positive. So that means this y is positive, right? You follow me? Therefore, sine is what? Is a positive in the first quadrant and second quadrant. You guys see that? You guys see that? Is everybody with me? Yes, so that's very obvious. Do you have to memorize this? Of course not. Look at the third and the fourth, okay? In the third quadrant, y is negative. Y is negative. In the numerator is negative. In the fourth quadrant, y is what? Negative. So negative divided by positive is what? It's negative. So in the third quadrant and the fourth quadrant, sine ratio is going to be, the output for sine is going to be negative, negative. Do you guys follow me? So that is also told by the definition. It just didn't say it because we are supposed to figure this out. You follow me? So you can see from that definition, we can dig. We can dig out so much information. We're not even done yet. We're far from done. We're far from done. Okay? But typically you will have a definition in chapter 1 in Trig, and they might talk about the sine thing in chapter 3 or chapter 4. Guess what? Chapter 1 and chapter 4 are related, and they're bounded by what? By definition. That's the power of definition. That's the power of definition. Now, I want you to think about cosine from this perspective. Okay, I want you to think about cosine from this perspective. So if I have a cosine of the angle, cosine angle is defined as x over r, right? And that cosine rule gives us a ratio. And if the terminal ends in the second quadrant, third quadrant, first quadrant, fourth quadrant, what can we expect for the sign of cosine? What would you do? You look at x over r, right? X over r. When x is positive, the ratio is positive. When x is negative, the ratio is going to be negative, right? So the whole process, we're using principle number 6, which is a positive divided by positive is positive, negative divided by positive is negative. Do you guys follow me? Principle number 6. Don't you forget those 6 principles. They're omnipresent. They're omnipresent. So in this case, for cosine, what are we going to be looking for? We're going to look at the sine of the x coordinate, which is over here, over here, over here, and over there. So whatever the sine of x in that quadrant, that will be the sine for cosine. Do you guys see that? Because it's embedded in the definition. It is embedded in the definition. Right? So what will be the sine of cosine in the first quadrant? Well, in the first quadrant, x is a positive, therefore this is a positive. In the second quadrant, x is negative, therefore cosine is going to be negative. In the third quadrant, cosine is x is negative, therefore this is going to be negative. In the fourth quadrant, x is positive, therefore that's positive. You guys follow me? Doesn't that start to look obvious? Does it start looking obvious? Could I hear something from you? Doesn't that start looking obvious? Yes?
Yeah.
It's obvious, right? You just have to look. You just have to look. And look at these 4 examples. Look at the 4 points we did in terms of ratio. They all confirm this, don't they? Even though that's just one example, they all confirm this, right? In the first quadrant, second quadrant, sine is positive, positive, negative, negative, positive, negative, negative, positive. And they all related to the fundamental. And they all related to the definition. Do you guys see that connection? Once you have that connection, it's obvious, isn't it? It's completely obvious. You just have to look. We just have to look. Okay, so now how about tangent? How about tangent? I want you guys to work out tangent, cotangent, cosecant, and secant. How about that? You know the example to work it out, right? Do you guys know that? I'm going to give you, how about 5 minutes? Breakout rooms. Shall we?
Professor, you want us to identify the sign of those trigonometric?
Yes.
Okay.
The sine of tangent and the sine of secant. How about that? You just do 2. The sine of tangent and the sine of secant.
Okay.
Okay, remember that, right? The sine of tangent and the sine of secant. I'm going to give you 5 minutes. Did you guys understand what I'm doing? So this time you are going to be the leader. Every one of you is going to be the leader to identify the sign for the output of different functions, and in particular, tangent and secant. Is that clear? So now the room is open. Okay, you just self-assign yourself to that room. If you stay in this room, I want you guys to make a similar table for tangent and the secant. Is my question clear? Is my
Yes.
question clear? Okay, go for it. Okay, I'm leaving you guys for work for a little bit. I need to make some adjustment here. 5, so that would be better. Okay, that's better. So So if we are aware of the definition constantly, a lot of things will look so obvious, okay? And we must learn, and you must learn how to use definition, which is a singular, very powerful weapon for your success. I'm sorry, I shouldn't use the word weapon, okay? Tool, important tool for your success. Okay, important tool for your success. Actually, I should do this. Let's see, that would make it better. I'm trying to, also give you guys some sign, positive, negative, negative. And this piece, I'm going to put it over here as well. So as the background, right? As a background. So cosine will be positive, negative, negative, positive. Heavy marketer, sorry. Okay. And all right. So you guys working out the tangent and the secant. Huh. I'm trying to balance these two softwares. They don't talk to each other. So I have to make these do these things. Okay. So clear all drawings. Let's see. So for tangent. Okay, so let me make this just a little bit smaller. 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 Right, for tangent of A, it would be y over x. Y over x. And the rule certainly would be tan y over x. Y over x represent what? Positive divided by positive is positive. So for tangent, right, is a positive divided by positive. This picture sometimes somewhere is messed up. But you guys understand what I'm saying, right? Negative, negative. So where's my negative, negative? Negative, negative. That needs to move. -3. 3. +3. Oh, sorry. Negative, negative. -3. That's better. Last one. Positive, negative. So that's -3, -3. Okay. So I'm going to use this one for everyone. Are you guys done? You guys done? Tangent and secant. Let's close all rooms. Sorry, guys. How much treasure can we dig out from the definition, right? How much treasure we can dig out from just the definition. Isn't that pretty amazing? Now we haven't done anything else. We just stay with definition. That's all we have done. That's all we have done. Right? We dig and dig and dig deep into the definition. And we have discovered, okay, we have discovered all of these. Isn't that pretty amazing? Are they back? Oh. I think I should change the colors for them all. Are they back? Okay, all right. You guys are back, right? Close all rooms. What do you think? Has it become so obvious to you when in time of need, you can figure out yourself? Yes? So let's do it again. For sine, we have noticed that sine is y over r. R is always positive. So whenever y is positive, right? This y is positive, therefore that's positive. And this y in the second quadrant for sine is going to be positive because that guy is positive, right? So you can just put these arrows here. Do you guys see that? Positive, positive, because the definition used the y, right? And in these, the definition used the y. Therefore, in the third quadrant and the fourth quadrant, the sign is negative. For cosine, we will be looking at what sign? The sign of x, 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 the first coordinate, right? So we figure out that cosine is positive, negative, negative, positive. Tangent, what did you do for tangent? Y divided by x. So positive divided by positive, you get positive. Positive divided by negative is negative. Negative divided by negative is positive. Negative divided by positive is negative. Do you guys follow me? Which principle have we used here? 6 mathematical principles. Which one did we use here? Go back to the flashcard. Which principle did we use here? Are you guys sleeping? Are you guys sleeping?
I'm checking.
You're checking. Very good. Keep checking. We only have 6 principles, right? What I just mentioned, which principle did we apply? Positive divided by positive is positive. Negative divided by positive is negative. Positive divided by negative is negative. Negative divided by negative is positive. Which principle is that? That's right, Kelly. Principle number 6. Right? Isn't that pretty neat? Now, I asked you guys to do cosecant. I asked you to do secant. What did you discover? What's the definition of secant? The definition of secant. What's the definition of secant?
R over X.
R over X. R over X and X over R, they're just reciprocal to each other, right? So if cosine is positive, negative, negative, positive, then secant will have the same sign with secant, right? Secant will have the same sign with the cosine, right? You see from that definition, one is X over R, the other one is R over X. So the sign will stay the same, aren't they? How about, how about cosecant? What's the definition of cosecant? It's R over Y, right? Do you think a cosecant will have the same sign arrangement as sine? Of course. One is Y divided by R, the other one is R divided by Y. They're gonna be the same sign, right? Principle number 6. Do you guys see that? Use your common sense. Use your basic understanding of the mathematical principles. You can figure out all by yourself. You don't need other people to tell you. You don't need to memorize a lot of things. Now, last but not least, how about cotangent? Cotangent is X over Y, right? Okay, did I make a mess here? I might have. Okay, because these things are moved. For tangent and cotangent, one is Y over X, the other one is X over Y. So how about their signs? Well, this is a positive divide by positive. Positive divide by negative, any order you do is going to be negative. Negative divide by negative, any order you do it is going to be positive. Negative divide by positive, any order you do it, you're going to get a negative. So sign is set. You guys follow me? Right? And for this reason, part of it, even though we have 6 trig functions, right? You do need to know all of them. But in many cases, the function that you use the most, okay, will be sine, cosine, tangent. Other functions you get to use for such as in calculus 2, right? But not nearly as much. Not nearly as much. Okay, that's just my 2 cents on that. So now we got the sign of these functions. Did you guys write them down? Do you understand why? How you find it? Once you know that, you don't need to have a summary table because you can just figure out from the definition. Isn't that definition powerful? Isn't that definition powerful? Chris, want to say something?
No, I was going to agree with you.
You agree with me, yeah. So you can figure out all from a definition, right? So let's continue to dig. Okay. The next thing we want to dig out is domain and range for these functions. Okay. In the typical trigonometry textbook, right? In the typical trig textbook, the definition will be given in the first chapter. Domain and range is typically talked about in chapter 4. Chapter 1, chapter 4. Guess what? When you're in chapter 4, you still have to think of definition. So now I'm going to bring them together. Okay, this is a cross-chapter study. A cross-chapter study. Let's still study the definition and our target. Okay, so I'm going to clean this up. Our target is to figure out the domain and range of these functions. I'm going to do one at a time. Okay, so our next target is domain and the range of the functions. And what are these functions? What are these functions? Right? Sine, cosine, tangent, cotangent, right? We have these definitions, right? We have the stage set. We have the stage set. And now from the definition, we want to figure out the domain and range. And yes, we can. They're all embedded. They're all embedded or inferred from the definition. Okay, from the definition. So now let's start from sine. Okay, the study of sine. Sine, if we look at the definition, right, with the stage set, we know it's a y over r. What kind of setting is it? So I'm going to bring back a picture we have done before. So this way, I hope this, this way you guys will have some idea, right? And you also have some visual. I want you guys to have that visual as well, right? We talk about we end up using unit circle, but we also talk about why we use unit circle. And it doesn't matter we use unit circle or not. So I'm going to bring back the unit circle. I'm also going to bring back another circle, which is not a unit circle, okay? So I'm just going to bring that over here. And I'm going to bring that a non-unit circle. Let's see. It's a 4 minus x squared. Okay, so I will make some adjustment. Okay, just give me some time. So remember, the goal is to figure out the domain and range. Figure out the domain and range from the definition. From the definition. Okay, so next, you don't see that circle yet, but I'm going to make you see it. Okay, you're going to see it now. So one is a unit circle, one is not a unit circle. Okay, by definition, right? If I work with the other unit circle, if I work with a non-unit circle, the meaning of x, the meaning of y, right? If I'm working with the non-unit circle, so this would be the point on the unit circle because I pick arbitrarily any point on the terminal, right? I'm quoting the definition. Do you guys hear me? I'm quoting the definition. I pick a point. I pick a point on the unit circle versus I pick a point on a non-unit circle. Suppose I work with a non-unit circle. Okay, I got a right triangle. I want to use a different color because I've been using different colors. So now on this triangle, right, the point is x comma y, right? This point is x, y. Geometrically, what is x, what is y? Geometrically, what is x, what is y? Sorry. Wait. The x would be this is x, right? And what is y? Y is the green, right? Y is the green, is that right? So this is x, and this is y. X should be blue, sorry. Now, I want you guys to compare the length. So this is x, okay? And what is the hypotenuse? This is the hypotenuse. The hypotenuse, I'm gonna make it r. If you look at the two legs of the right triangle, r is always the longest, isn't it? Yes, is r always the longest? Yeah? Yes? The hypotenuse is always higher, it's always longer than the legs, right? Will they ever be equal? Can the hypotenuse equals to one of the legs? Yes, it can happen. But that would be the extreme case. That it's no longer a triangle. But that does happen. So one of the legs could be the same as the radius. Okay, for example, if your terminal on x-axis or y-axis, in those cases, you do have the r is equal, you know, r has the same, the hypotenuse has the same length as one of the legs. Okay, so as a result, what can we say about the value of y over r? What can we say about that value? That value is always going to be less than or equals to 1, larger than or equals to -1. That is the range of sine. Do you guys follow me? Did we cover this? Refresh me because I'm a little confused. Did I cover this, Bruce?
Professor, not in this class and not in this class.
But someone, but Elijah said I did.
Oh, is that
I
right?
think you may have touched up on it.
Okay.
You just covered only sin and cosine, not the other principles.
Oh, okay. All right. But can you see that this ratio is between -1 and +1? No less than -1, no larger than 1. Do you agree with me? Right? So let's look at some extreme cases. Let's look at some extreme cases. Okay. What do I mean by extreme cases? Right? Because your terminal can be where? Your terminal can be this one. And your terminal can be this one. Your terminal can be this guy. And your terminal can also be this guy. And of course, it can be everything in between, right? In those extreme cases, for example, in the first case, in this case, right? What is that point on the line? This point is going to be what? The x is the same as r. And the y is 0. In this case, y divided by r is going to be 0, right? Now let's look at that point. That point, x is going to be 0. Y is going to be the same as r, which is the hypotenuse. In that case, r divided by r is 1. So that's the largest value it can be. You follow me? Now, look at this point. At this point, x is 0, y is -r. In that case, y divided by r is going to be -1. Everything in between is going to be between -1 to +1. Therefore, the range of sine is this. Did you guys write it down? Did you guys mark those? Okay, so the range of sine, okay, the range of sine, I'm going to put the definition over here. And the range of sine is going to be between, it's going to be always between -1 and +1. Okay, so give my mess. So the domain and range is already told. Domain, it can be any angle because you can measure any angle counterclockwise, clockwise. Clockwise, you get negative angle. Counterclockwise, you get positive angle. There's no limitation of which angle you can use. Therefore, the domain for that, for sine, is all real numbers. Okay, so the domain for A is all real numbers. Okay, and the range That's the range expression. You must know, you must understand, because you are going to use it in calculus class. It could easily earn you 10 more points or more. Okay. You guys follow me?
Professor, this is serious. One maybe comment here or question regarding the domain of sine A, which is negative infinity to infinity, right?
Mhm.
Is that since the input domain is the angle, any
Right.
angle, any values, is that the maybe good idea to add the unit, because angle would be measured with degrees or radian, so that helps the students to remember, or us, all of us.
It doesn't matter you use angle or radians at this point.
Okay.
Okay, we will eventually get you to use the radians, but at this point, it doesn't make any difference. You can use any degrees or you can use any radians.
Right, this negative infinity to infinity, algebraically speaking, is the all real number. But here in the trigonometry, and then especially domain and range, this negative infinity to infinity, it could not be negative, I mean, 2 miles or 2 inches. It has to be 2 degrees, right?
It's either degree or radians.
Yes.
Radians basically puts you in a real number.
Right, right. So,
right? Radian basically puts you a real number. You don't have to mention degree. So if you, most of the, we want you to use radian because radian is used a lot. But using radian, we have another reason. Okay, I will come to, I will show you. But for now, you need to understand whether you choose from negative infinity degrees to positive infinity degrees, or you choose negative real number, positive real number, which by default will be considered as radians. And
yes.
the range is always like that.
Thank you very much, Professor.
Mm-hmm.
If negative infinity degrees to positive infinity degrees, that was perfect.
Correct. And the other useful form that you're going to have is the absolute value of sine of A of any angle is less than equals to 1. The last form I'm going to mention is this interval. Okay, this interval. There's also an expression of domain for sine. Some of you might know this. This one is the least useful. Okay, this form is the least useful. Why do I say that? It's nice for you to know this. I'm not saying this is totally useful, but I say it's the least useful. I have students that came to my calculus class, and if I ask them the range of sine, they will give me this interval. But when I use this to work their calculus questions, the student cannot get it. It takes a couple weeks, maybe by the time a midterm exam, and the students start getting it. By that time, the student has lost 10, 20 points. So that's why I resolved to teach you guys inequality to express whenever we can. I say whenever we can. For example, for domain, this is from negative infinity to positive infinity. There's no proper inequality for it, right? But here you have to. You need this form for that 10 point, 20 point you're going to earn in calculus. Okay, chapter one. So the sooner you get this, the better off you'll be. You can start earning points already. Okay, so some of the points I guarantee you to earn, it's not going to happen in this class. Even though I will, I drill you over and over again. These questions will show up on your quiz over and over again, on your exam, on your midterm, on your final. So you have already started earning points. Wait until you get to calculus class. You're going to earn even more points. Okay. So that's the end of the class today. Next week, we're going to continue. We're going to continue. I think I mentioned in this class about the domain. Okay. And I also used the other perspective. Didn't I? We did. Okay. The other perspective is that could I take a little bit more time? Okay. Some of you came to pre-calculus class or calculus class, and that person remembered this vividly very well. I think we talked about this yesterday. Is that when I ask them a domain and range and make sure they understand what this means. Right? All you have to do is just look at this, right? We know the blue numbers is for what? Is for sine value, right? You guys follow me? I think we did this yesterday, but we're doing it again because now they're together. The blue numbers, look at the value of these blue numbers. What is the smallest blue number you see? -1, right? What is the largest you see? This is the smallest, and that is the largest. All the other blue numbers are everything in between. And yesterday we probably have done the bars, right? The vertical bars, didn't we? It all tell us one thing and one thing only. It tells us that sine of any angle is always the output. Okay, A is the input. The output is always between -1 and +1. That's what it tells us. Okay? Are you with me?
Yes.
All right, so we're gonna repeat a lot of the important things over and over, but for one purpose and one purpose only, for your ultimate success in calculus classes. Okay. With that said and promised, okay, and you promised me you're gonna work hard on it, and I promise you I work hardest for you, and I'll see you guys on Monday.
Thank you, Professor. Have a nice weekend.
Thank you. Thank you.
Thanks for the lecture, Professor. Have a nice weekend.
You too. Thank you. Wonderful job.
Thank you.
Thank you,
Thank you.
Professor.
Of course, my great pleasure.